Hey, good morning. Welcome to the course on data lakes. So today we're going to take up an example of my recent project that we did, and this is going to talk through like the whole architecture, the data flow of how the data lake was set up and how it's being used. To set up the background, this is for a data company which processes data from the web and then build some analytics around the data and then sells it to uh, like their customers. And the data that they use is Amazon seller data. So they go through Amazon's website and then scrape the data from different products that sellers sell, see what category it is, see how their products are placed, see how their products are um, like performing, and compare that with their inventories, compare that with how they are uh, uh, thinking about sales will progress over the next few months, and then give them some intelligence around it. And that's the service they provide to the Amazon sellers. And the people who sell on Amazon go to this data company and then buy this information, um, like whenever they need more analytics around the data, and they want to be able to sell more uh, products to the customers. So with that background, let's start with how this data originates. So this data um, is is a lot of web scraping. They have their own C++ scrapers. No, I was not part of that. This is prior to landing on the data lake. So they have a lot of web scrapers which they have to change multiple times because Amazon or other websites that they scrape from keep changing their web layout. So they'll have to keep changing the code. So they'll have to verify that today's batch ran and they were able to scrape all the data correctly. If not, go and figure out what went wrong, change the code, and then uh, like land all the information that comes out from web scraping. And then they load it onto Parquet files. There's also a couple of third-party APIs that they use. They use a third-party website called SimilarWeb, which is a website which ranks multiple websites and multiple URLs. So that is one piece of information that they add on to what they already get. They also use another piece of information which also provides them information about um, like the category of multiple products and how the categories are performing. So they use two third-party API data. All this information um, gets loaded on um, to their data lake, and their data lake is a Spark based system, and they did not use any cloud system. Um, they were they have their own bare metal servers. Like they had 25 nodes and off of Spark nodes, and then they built their system. And as for uh, what the system did, from the scraped data, um, the Parquet files that were landed on to their servers, from that they had the jobs that ran and passed the product information, products, the category information, and then they they had access to the sellers' retail data analytics. So Amazon provides sellers with retail data analytics dashboards, and there's a basic dashboard, and some sellers, if they buy a premium, they get a premium dashboard. So depending on whether you're a basic seller or a premium seller, uh, like that that seller's data was downloaded. So if like they had about 150 clients, all the 150 clients retail analytics data was brought in here, And there were two categories. So some of them were basic, so they did not have the premium. So the, the basic data was brought in. For the others, the detailed data was brought in. And third party API was also called to get the information about each of these seller rankings, and to figure out also about the website rankings. So they got two pieces of information from two different third party providers. And all this information, um, like all the product and the category information, was used to do a lot of statistical analysis to understand which product, and each product would have multiple variations like different colors, different styles, say different sizes. So those are called variations. So products, how, what kind of variations they have, and what kind of category they form under, and within the category, like what, um, like how are they performing, um, and these are category that Amazon provides in itself. So Amazon has a major category and a subcategory that they have on the website. So that is what is being used. But this was used to do a lot of statistical analysis and calculation to figure out how many were sold in the previous day, and how did it perform over the last 7 days, how did it perform over the previous year. So all that is used to do some statistical analysis and to calculate what would be the seller rank next week. That was kind of the output. Um, but not only that, we also had some information from the retail data analytics and the third party API. So that data was again used to do some client specific predictions and client specific calculations. So based on each client, what would be their specific prediction calculations, and these two data were again merged, and then that got to client specific prediction of what kind of bestseller rank they'll be, and what kind of um, product inventory they have, how much inventory they should add, um, what kind of promotions they should provide, and those kind of analytics were brought together in this area. And then this information was then exported over as files, um, as Parquet files, and then like some of the clients directly used the Parquet files. So those Parquet files were sent to them, but most clients had a dashboard that they used, and it was brought into like tables, and this is a columnar database table, and it is also brought into um, my RDBMS table, and the RDBMS table was used for mostly like not analytical data, but the static data that comes out, kind of who are the sellers, who are the what kind of plan they have with the company, like what do they have a basic plan with Amazon, do they have a premium plan with Amazon, what kind of products they have. So that somewhat static information was stored in the RDBMS table in the bottom, which shows 600 tables, and the top was a columnar table which has like 700 tables, and that had like 4 terabytes of data, and each day there was like 5 GB of data added each day. Um, the kind of technology they used to do all this was Apache Airflow, and I had to do a lot of Scala code to do all these calculations, and like build out statistical analysis, then provide client specific reports. Um, yeah, Spark was the basics. Like when we use Scala, it's typically Spark that is the underlying basis. So Spark was the technology that allowed parallel computing, and being able to spread your compute across nodes and do all the calculations and then bring them back together. Um, all the intermediate files were stored in Parquet. All the persistent data was stored in um, these ClickHouse tables and MySQL tables. Um, that is the tech stack that we used. If you have any questions around data lakes and data warehouses, so this you can let me know in the comments, and I'll try to get back to you, answering whatever I know. Um so this portion before the data warehouse is the data lake, where we land all the files as they come in. And as the web scraping changes, as the web adds more fields, adds less fields, we add more information or have different layouts. And those are still going to be in Parquet files, which is a column-based layout. And so these files are going to change in layout um, as this is being landed in a data lake and not staged in a database. Um, the schema of the database need not be changed in case if it's a fixed schema, in case a field gets added or some field type changes. You don't have to go and change the data schema. Given this is the data lake, we can land the data from web scraping onto that area without worrying about the schema. So these are called schema on read. Um, that's the advantage of using this type of data lakes. Okay, that's all I had for today's session. If you have any more questions, please let me know. Thank you. Okay, this flow had around 1,000+ jobs per day, and this included like the Apache Airflow was able to. So one piece of information I forgot to let you know. So this, when we set up the jobs in Apache Airflow, the Apache Airflow has something called DAGs. So the DAGs are defined based on um, the Python code you write, and each DAG has a number of tasks. And the tasks call like each task is executed by calling an operator. So we built our own custom operators. Each operator to call a Scala job, it had to use the bash operator, and within the bash operator, we give the link to the jar file, to the actual program that we're running, and then to the Spark system that we want to access. So we give all the information and give any parameters at the end, and all that goes in the bash command, and that gets called by the custom operator, and the custom operator uses all this information to actually execute the Scala job. And those are part of tasks, and those tasks are part of the DAG. And we had a DAG that built um, the flows for each country. So it the Apache Airflow job would kick up every day in the morning, and that would in turn kick off like a Python flow where it will go to the database, look up all the customer names that are there in the database for that country, and like for all those customers, it will build up um, the flow of data parsing and the third-party API lookup and the retail data analytics lookup based on whether they are a premium customer or a basic customer, and all that information is done by like it's done dynamically by Airflow. So if we add more records, more customers to the database, Apache Airflow would build the DAG uh, based on the number of customers. So it'll dynamically expand that, and that DAG, after this DAG builds a DAG with all the customer names, that new DAG is executed after that. So this included like 1,000+ job, including all the countries that they provided service to. That was like I think 16 countries or something. And then the size of the file system was 100 terabytes, and we were having an intermediate file system of 10 GB per day, which we are adding. And yeah, this 10 GB per day could be removed after like 7 days, and that was intermediate storage. And this 10 terabytes of file system um, was kind of the size of the 100 terabytes is the size of the data lake in itself. Okay, that's exactly what I had for today. Thank you so much for joining us.